Hi, my name is Madeline Brandt and I'm a mathematician. I get asked all the time for examples of real-world applications of math. So today, I thought I would give an example of how to apply the quadratic equation to a real-life problem. I love climbing, so this example comes from a climbing competition. In the competition, climbers compete to climb an arch underneath a bridge in Spain. Today, I'm going to use quadratic equations to analyze a fall taken by Rustam Gelmanov in the semifinals of this competition. In this video, I'm going to solve three problems. First, I'm going to estimate the height of the fall using a quadratic formula. Second, I'm going to write down an equation describing the shape of the bridge. Last, I'm going to calculate the horizontal distance climbed by Rustam Gelmanov before he fell using the quadratic formula. Alright, so let's get started. I decided to model the bridge as a circle. We're going to let the radius of this circle be r, and I'm going to call the point where the left end of the arch meets the water the origin 0, 0. Next, I'm going to mark the point where Rustam Gelmanov falls in his climb. The coordinates of this point will be called x, h. So in this situation, h is the height that he climbed to before he fell. First, I'm going to calculate this quantity h. By analyzing the footage from when his hand left the wall to when his body was fully submerged in water, we can see that his fall took about 1.3 seconds. His acceleration is approximately 10 meters per second squared. There is a formula for the total height of his fall in terms of the time. In total, this tells us that he fell approximately 8.45 meters or 27.72 feet. So this is the quantity h in our diagram. Now I'm going to estimate the radius of the bridge arch by zooming in a bit on this footage. Rustam Gelmanov is a height of 1.68 meters. To me, it looks like the distance from his hand to the top of the arch is about half of the length of his height. So that gives us an additional 0.84 meters. In total, this tells us that the radius of the bridge arch is the height h that we already found plus 0.84 meters. So this gives us a radius of 9.29 meters, which is approximately 30.5 feet. Now we can write down an equation for the arch of the bridge. I'm going to start with the equation for a circle, which is y squared plus x squared equals r squared, where r is the radius. We can shift this to the right by subtracting r from x. So we get y squared plus x minus r squared is equal to r squared. From this, we'll move the x part to the right side of the formula, isolating y, and then take the square root. In this scenario, we want to take the positive square root so that we get a semicircle in the upper half plane. This gives us the following bridge equation. Now I want to solve for x, the location of Rustam Gelmanov when he fell. So I'm going to plug in h for y, since h is the height of his fall, and then I will solve for x. I can rewrite this formula as the following quadratic equation. X squared minus 2rx plus h squared is equal to 0. Now, this quadratic formula can be solved using the quadratic equation. The quadratic equation tells us the zeros of a degree 2 polynomial like this. So, this tells us that x is equal to 2r plus or minus the square root of 4r squared minus 4h squared over 2, which simplifies to r plus or minus r squared minus h squared. We already know the values of r and h from our previous calculations, so we can plug those into this formula to get two options for the value of x. This corresponds to the symmetry in the problem. Rustam Gelmanov could have started climbing from the left end of the bridge or the right end of the bridge. Since he started climbing from the right end of the bridge, we know that his location has to be the greater of the two distances, which is 13.15. However, this other number, 5.429, actually tells us the horizontal distance that he climbed. This is about 17.8 feet. In this video, I used the quadratic formula to analyze the climb of Rustam Gelmanov in a 2014 climbing competition. I hope that you enjoyed this video and that you learned something about how to apply quadratic equations to real life scenarios.